Next one is the measuring an input size. Almost all algorithms run longer on longer inputs. If the input given is very small, our program works faster. If the input given is very larger, then our program or the algorithms take more time. The input can be measured. It's a logical to investigate an algorithm's efficiency as a function of some parameter n indicating the algorithm's input size. That means we calculate the efficiency by some function. For that function we are giving an input as a n. For some algorithms, the input size is easily measured. For example, when you are using some sorting, searching, as well as some other list operations, where the size is called as the number of items in the list. As the number of items increase, the algorithm efficiency, algorithm time taken is also increase. For example, in sorting, if the array size is very small, it will sort quickly. But if the array size is very large, it will take more time. So here the input size is the number of elements in the list. As the number of elements increases, it will take more time for the sorting. But in some situations, the input size won't matter. What matters here, for example, if you want to calculate the multiplication of matrix, the first condition is here. If you are having n into n number of matrices, the inputs is called as n here. The total number of rows, total number of column is n. As the n value increases, the product of matrix is also increase. It will take more time for the calculation. The another one is the input is the total number of elements in the matrices, that is capital N. Here sometimes the matrices are not square. In that case, we have to consider the total number of elements in the matrices. In reality, we can easily switch from the first input to the second input, and second input to the first input. But when you take n as the input, the efficiency is different from the capital N as the input. In both the case, the efficiency will be changed even for the same matrix. In the next one, in some cases we are using some numeric value as the numeric value or integer value as the input. In this case, as the magnitude of the number increases, the efficiency of the algorithm is also changing. If the value given is very large, the input is also size is also large, and the algorithm is very slow. For example, if you are calculating a factorial of a number, if the number is very small, the execution will take less time. As the value given, factorial value is given very large, the calculation of factorial is also large. That is depending on the magnitude of the value.